All right, find the values where the function is not continuous. F of x is equal to secant of x. Well, this is a fraction. What we're going to do is rewrite. Anywhere the denominator is equal to 0, that's where this function is undefined. Now, to know where this value is equal to 0, we either know it, or if you're unsure, we do remember the graph of the cosine function. Anywhere cosine is equal to 0, that's where cosine crosses the axis, and we know where those are. So we know we must exclude anywhere cosine of x is equal to 0. And that implies x is equal to. So this is pi over 2. This is 3 pi over 2. The next one is 5 pi over 2. Next one is 7 pi over 2. 9 pi over 2. I think we're getting the pattern here. But we also have negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. I think we have that pattern. These are the odd multiples of pi over 2. The odd multiples of pi over 2. So one version is to write that. We must exclude odd multiples of pi over 2. Here, I'll just write here. This is 100% absolutely fine, wonderful, grand, and glorious. This is correct. If that's what you write, that is fine by me. You're good to go. Odd multiples of pi over 2. There's another way to write that. If you remember from your glory days in trigonometry, when you studied trigonometry, you probably learned a different way to write this. Remember, odd, the word odd can mean two. Remember, so let's recall. Let's have a little review session here. 2n, or I like to use k. 2k, no matter what integer value, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, no matter what integer value you pick for k, 2 times that is an even number. This is the generic representation of an even number. If k is 3, then this is 6, it's even. If k is 11, this is 22, it's even. If k is negative 4, this is negative 8, it's even. So this is the generic representation of an even number. This is the generic representation of an odd number. An odd number. 2k, if k is equal to 1, this is 2 times 1 is 2, plus 1 is 3. So that's an odd number. If k is equal to 6, this is 12 plus 1 is 13. That's an odd number. If k is equal to negative 10, this is negative 20 plus 1 is negative 19. So no matter what value of k we select, this is going to end up being an odd number. No matter what value of k we select, this ends up being an even number. So anytime you want to write the generic formula way, the formula way to write a generic odd number, it's 2k plus 1. Odd, so I'm going to write out in symbols what I've written in words here. Odd multiples of pi over 2. This is the symbolic way to write that expression. And if you cannot smell a multiple choice question coming right here, you are not sniffing very hard. This should be just blatantly obvious that there's a multiple choice question somewhere hanging around this notion. So if you're asked to find where are the values, where the values are that are the function is not continuous, secant is not continuous whenever cosine is equal to 0. This might be a way to state it. This might be a way to state it. These are equivalent. Suppose we wanted, we don't in this case, suppose we wanted even multiples of pi. Suppose we wanted all the even multiples of pi, then that would be 2 times k times pi. Even multiples of pi. If I want even multiples of pi over 2 for some reason, even multiples of pi over 2, I don't know why you'd want that, but that would be 2k times pi over 2. If I want odd multiples of pi, 2k plus 1 times pi. These are the odd multiples of pi. So you may state it with words, it may be stated with symbols, but you should understand that those are equivalent, and you should be able to freely translate between these two. If you have this and the answer sheet has this, you need to recognize they're the same thing, and vice versa. If you have this and the answer sheet has this, you should recognize those are the same thing. So the big deal of the day is for the trigonometric functions, it's not hard to see where they are not continuous. They are not continuous where their denominators are equal to 0. And from that, we should be able to determine those specific values, in this case, odd multiples of pi over 2. Now, let's muddy the water a little bit. Suppose we have f of x is equal to secant of x plus 1 over x minus 4. I'm just pulling this out of the hat. Then you handle each of them separately. We have already done this. We want to find the values where the function is not continuous. You handle them each separately. Find the values here, find the values here, and put them together. So we must exclude, and we've already seen, this is the odd multiples of pi over 2, odd multiples of pi over 2, and, but that's fine. And where is this undefined? This is undefined where the denominator is equal to 0. And if you don't know already, that's at 4. So at x equal odd multiples of pi over 2, and at x equals 4. So this is what we must exclude. These are the values that are not in the domain. The values that are in the domain is everything else. Everything except these values. These are the values excluded from the domain. There are other ways to write this, but this will suffice for our purposes.